All right, how's it going?
Quick question. What was your background?
I don't know, something I found. I thought it looked cool.
Concept art from a canceled Star Wars game.
It's my home. No.
I knew it. It's like,
Is it?
I knew it was Star Wars. Yeah, it's like 13 or something like that.
Oh, cool. Okay. Yeah, that's how I feel some days. So thought I'd put it up.
It almost looks like Bioshock.
Yeah. All right. Yeah. So attendance is dropping off quickly. Which is too bad because we're going over the midterm today. I'm going to tell you all about the midterm. So.
It's on Friday.
And midterm is on Friday. It's a good question. See, I want to talk about ODP 414. I want to talk about the new ODP 415. I want to talk about, I want to refresh Git because I mostly talked about how to use Git in a perfect world. But when things go wrong, I want to tell you what you can do about it to like sort of get things back to a known state. So we'll talk about Git from that perspective, and then I'll talk about the midterm guide that's been posted on Canvas. Questions before we start all of that?
Can there be questions on the midterm?
Sure.
Sweet, okay. I have quite a few though. I don't know.
Okay, let's wait till we get to the midterm then. All right, but then you can go crazy. All right.
So if you're checking a string and you're trying to do like a range of ASCII codes, can you do quotation marks? Like say you're looking for letters like A.
Yeah.
And then.
So yeah, that's usually legal.
Usually.
Not all of them in the court. Well, what do you mean by usually?
So that would work as a range.
That'll tell you if your character is between A and Z. Yeah. But I say usually because it kind of assumes that we're using ASCII, right? And that's not always necessarily a good assumption. So there was a very popular code called ASCII, and I say very popular as in this was the only code that people were using for a long time because this is what IBM used, and this was what it looked like, right? So it goes like A through L, and then there's a bunch of empty spaces, and then J, K, L, and it was just weird, right? And so it would not work on a case like that. I don't expect us to bump into ASCII today. But if you want to know if a character is a letter, there's a utility in C called isLetter. And that's the way you really want to do this. All right, is alpha, sorry. So there's is alphanumeric, is ASCII, is blank, is control, and so on. These are set up per installation. So if I happen to be on a weird computer that doesn't use ASCII codes and things aren't numeric, I can still say is alpha, and it'll give me back a true or a false, depending on whether the character I pass to it is alphanumeric. Same thing with uppercase, lowercase. There's an is upper, there's an is lower. And there's also things like 2 upper, 2 lower, that'll do conversions for me. So I don't need to add 32 to change from uppercase to lowercase and so on. So I recommend those, and all of those you just need to include ctype.h. And then they're like ready to go. And then your code's portable to whatever.
Thank you.
Yeah. Other stuff? All right, how'd the mix function work out?
Perfect.
Perfect, excellent. So there's sample code for mixing 2 strings together. And I used a pair of pointers here, one for the input, one for the output. So inloc is the location in the input strings. And since the 2 strings are equal length and we're just interleaving, I just need 1 pointer for that. And then outloc is the location in the output string, which is called out. It's the 3rd argument to the function. And I initialize outloc to 0, I initialize inloc to 0. I'm using a for loop to go through the input, so it's our standard 0 to string length minus 1. And then this is this little algorithm that we put together on paper yesterday with some hand waving, which basically said take the first character in your first string, that's this, and assign it to the current location in the output string. So that's out bracket outlook, and I'm doing a post increment here. I could just increment outlook after the assignment. And then I read the same character from the second string, copy that to the output and increment. And my kind of mental picture of this variable outlook is this is always where we should write the next character in the output array. So it starts off at 0, that's where we should write the next character is location 0. So if I believe that, when this loop finishes, outlook should still be the location for the next character, so that's where I drop the null terminator. You can kind of cheat and just go less than or equal to string length, and it'll automatically copy 2 null terminators at the end. I could be mean and make your string not long enough for both of those, but I didn't do that, I don't think. But this is the other way. So again, a trick to these kinds of things is sort of think about how you do the algorithm yourself. Right, and then try to break it down into a series of steps, and then try to turn that into an algorithm, and then convert that algorithm into whatever your target language is. Yeah?
So with the increment operator, if it goes after, it uses the value and then increments.
Exactly. So when you say outlook plus plus, it uses the value and then it increments it. If you say plus plus outlook, it increments it first and then it uses the value. And if you've done 270, this is pre-inc, post-inc. In the special function register. Sorry for the flashbacks. All right, any other questions? How did I test this? Oh, we did some test code yesterday, actually, just that main program.
Okay.
So, and the actual assess code, the actual assess code is reading from standard in and getting rid of the null terminator and then just mixing together. So I could test it by just feeding different strings in through standard in. And I think I deleted my test code from yesterday. But you can do something like something like that. It's not terribly convenient, but that would mix those two strings together, store the result in temp, and then just print it out. And then I can change that mix call with different arguments to try different strings. All right, any other questions? All right, so let's look at ODP 415. So 415 is actually kind of fun. It actually does something. So 415 is a bit of a calculator program. It's going to take a string that represents a simple arithmetic expression. It's going to evaluate the expression and then return the value of it. So you're making a function called calc. It accepts a character array, that's a string, and it returns an integer. And if the argument is something in the form number, operator, number, like 14 plus 7, then it should evaluate what that's equal to and return the answer as the function value. So you can assume there's no spaces in the input string, okay? If it has the form number, operator, number, and the operator is either a plus, a minus, a star, or a slash, then it should evaluate what that's equal to and return that as the function's value. And so you want to parse it using Sscanf with a %d, %c, %d. This should match an integer, a character, and an integer. If it does not match that pattern, return a -1. Don't print an error message, just return -1. If it matches this pattern, but the character is not a plus, minus, times, or divide, then return -2. If it matches this and the character is a plus, minus, times, or divide, do the addition, subtraction, multiplication, or division of the two numbers and return the answer.
When
Yeah.
you're passing stuff into a function,
Mhm.
like a string, do you have to pass it as a variable, or can you put, like, in this case, calc, and then two double quotes?
You
and then
should be able to do double quotes.
We're about to find out.
Good, let me know. Yeah, I'm pretty sure that's what I did in my test code. All right, so test your code, and there's a lot of things to test in here, and then go ahead, link it with the test bed, and assess it. And so here's some examples of what your function should do. So your string does not include the angle brackets. Assuming your string is just 9 plus sign 9, 3 characters, the function should return 18, 9 plus 9. If it's 9 equals sign 8, that's not in, that's in the correct format, but equal is not a valid operator. That's an error -2, so return -2. If it's 9 minus 8, that's valid, return 9 minus 8. If it's letter plus letter, that's not in the required form, that's an error -1. And these are integers, so if you have two integers and you divide them in C, it's just going to truncate them. So 9 divided by 8 should be 1. 8 divided by 9 should be 0. You don't have to do anything special to make that happen. That's what integers do when you divide them. So just do multiplication, division, addition, or subtraction, and return the answer. So 2 comma 3, comma is not an operator, that returns a -2. 2 plus ha is not an integer, that returns -1.
It works.
Cool. So test an empty string, make sure that works, and try some of these. We'll come up with some test cases. So the error checking is pretty straightforward, but let's look at the algorithm for this, and the error checking will kind of fall out from that. So how do we do this? Someone comes up to you and says, please evaluate this string for me and tell me what that's equal to. Well, how do we do this? We somehow know that this is one of the numbers, and this is the other number, and this is the thing in between, and we know this means multiplication, and so we say 12 times 8, and that's 96. Thank you. I was about to squirm. And so we would say the answer is 96. Okay, if we want to write a program that'll do this, the first part is breaking it into these pieces. We need to say, okay, there's a number over here, and there's a number over here, and there's an operator in the middle. And we need to somehow say number 1 equals 12, number 2 equals 8, and operator is a star. And that's what Sscanf will do for us. We have to do very little work. So if this is, a string maybe called input, all we have to do is Sscanf input %d, %c, %d, and then address of num1, address of operator, and address of num2. Okay, so let's talk about operator. Assuming that we did character operator and integer num1, num2. Okay, we've been doing scanf with integers since 121, right? When you have an integer, you use a %d as your format, and we use ampersand, name of the variable. Okay, for integers, forget about the rest. Right, so we know that. Characters are basically like integers. They're short, they're only 8 bits, but it's basically like an integer. So if we have a character operator, we use a %c for character, but we still use ampersand, name of the variable. And that's really important. The only time really right now that we're not going to use an ampersand is when we have a string, which is a character star something. Okay, if we have an array, we don't need an ampersand. Strings are arrays, so if we have a string, we don't need an ampersand. Car star is a string, is an array, so we don't need an ampersand. So let me warn you, if you put an ampersand here, if you don't put an ampersand here, if you put brackets after this, if you put brackets here, if you put a star here, if you put a star here, it will compile with warnings and it'll run and it'll probably seg fault. Okay? So if you make sure that you're using a character, it's just character space and name of the character, and in your scanf it's just %c and then ampersand name of the character variable, right? You'll avoid all those problems. Otherwise, all bets are off, right? So don't be someone who's struggling at 2 in the morning getting seg faults with all this kind of stuff because you did car star OPR or something like that, right? There's really, it's not like the compiler is going to give you a warning saying, warning, you probably just want a character operator here without the star, right? It's going to give you some weird warning about, you know, reference to pointer, making a comparison with integer without cast or something like that, and it's going to seg fault, and it's not going to give you any more help than that. So think of characters as integers, right? And do what you would do with an integer. Just say car operator, integer num1, ampersand num1, ampersand operator. Okay, and if you want to work with a character, it's single quotes. Okay, as soon as you put in double quotes, you're making a string, which is an array. All right, so keep that in mind. And then, yeah, Sscanf basically does this parsing for us. So what should Sscanf return? We're trying to extract 1, 2, 3 pieces of information from our string. We're trying to store them in 1, 2, 3 variables. So if everything goes according to plan, this should return a 3. So if it returns a 3, you've got an integer, a character, and an integer. If it doesn't return a 3, it's not in this format, and that's where we throw an error -1. So maybe you want to say, if this is not equal to 3, return a -1. And then you're done with that error case. If it does return a 3, well, now you've got this setup, number 1, number 2, and operator. So how do we combine these 4 if statements? We'll do it.
And not equal to.
And a not equal to. So you could say if operator equals star, then return num1 times num2. If operator equals plus, return num1 plus num2.
I did the switch statement.
Or do a switch statement. If you like switches, this is a perfect setup for a switch. If you have 4 if statements to see if it's a plus, a minus, a star, or a slash, and you return after each of those, if you get to your 5th statement, it wasn't any of those, it means you have an operator that you don't recognize. That's when you throw your error 2, -2. It's an unknown operator.
I did that at the beginning. I checked if, like I said, if not equal to, and then all 4 of them.
Okay,
And returned the -2.
that works perfectly well too. So different ways you can do this. But basically, once you have 2 numbers and you have an operator as a character, Now write some code to put those together, and there's really no magic, right? It's really, you can do for if statements. It's not like we somehow turn that operator character into an operation that does multiplication. You could do that in some languages, and that gets into fun stuff. But you can just sort of tell the computer what you want it to do. If this is a star, multiply these numbers and return it. So to me, this is kind of a fun function to write because it actually does something arguably useful. And then test it. Print out calc parentheses 9 plus 9 in quotes. Print calc parentheses quote, 12 times 8. And see if it prints out the right thing. And try some error cases. All right, questions on that? Hopefully Canvas does not crash today. But you should be able to find this on the video if it does. Speaking of Canvas, I posted an announcement yesterday for this class. Start sending me direct email in maciasclark.edu if you have to get a hold of me, because I've had a number of issues with Canvas email, especially the past week, and some of the issues it hasn't actually told me there's issues. It's just dropped things silently without letting me know. So if you definitely want to reach me, do a regular email outside of Canvas. Okay. And this unfortunately includes if I put a submission comment on your assignment, if I say, I'm not sure what you did here, please add another paragraph or something like that. If you put a submission comment back in there, it's going to come through Canvas email, and I may not be able to reply to it and so on and so forth. So if you want to reach me, if you're just putting a comment in there and I'm going to look at your submission again, I'll see it in the comments. But if you definitely want to reach me, send a regular email. All right, so let's talk about Git. So as I said, we've gone through Git a number of times. There's resources on Canvas, which are great if everything works according to plan. But things don't always go according to plan. So I want to review really quickly how we use Git in an ideal setting. Then I want to talk about some of the ways you can back things out if something has gone wrong. Let's find a directory. That looks good. All right, so here's a directory called imp. And if I do an ls-a, that shows me all my files in this directory. I do not see a .git. Okay, so I'm really confident that this directory is not under Git's control right now. And if I say git status, it'll confirm I'm not in a Git repository. When you start a new project, this should be your state. You should not be starting in a Git repository. You should be starting in a totally new directory. Okay. If you find that there's a Git repository in your directory already, chances are you've already done some project in this directory, and there's a good chance it's already been Git remote added to some repository on GitLab, and when you try to push this over to a new repository, it's going to complain at you, right? So the first thing is always try to start in a new directory. The worst counterexample of this is if you're doing everything from your home directory, every project is in one directory, well, every time that you need to push it over to GitLab, it's already been linked to another repository, so you got to undo that and push it back over to a new one, and you're really kind of working orthogonal to how Git is supposed to be managing things and making your life easier. So make a new directory. Okay, so my directory is called imp, and it's never been put under Git control. Okay, so one time only, I'm going to say git init, and it should say initialize an empty Git repository. If I say git init and it says reinitialized existing repository, something's wrong. Okay, there's already a Git repository here. So if you don't know exactly why that happened and what's going on, make a new directory, copy your files over, start fresh. Right? You can rename your old directory so you don't have to delete it, but move it out of the way, make your new HL or PA3 or whatever, right? And do a git init. All right, and let's say I want to add my Java files to my Git repository. Okay, there's two steps anytime that you want to put something into your repo. There's adding it to what's called the staging area, and then there's committing the changes that are in the staging area to the repository. It's always two steps. So I'm going to say git add star.java. That adds my files to the staging area. They're not in the repository yet. They're just kind of in this holding area. If I say git commit, then it'll take those changes and push them into the repository. So adding some Java code. Okay, and now I've got two things in my repository. Now I haven't touched GitLab yet. This is all just local. Nothing to do with GitLab at this point. So I'm going to make a README, and this is my README with typos. And I want to put that in my repository, same two steps. Git add and git commit. If I want to change my README, and I want to put that in my repository, same two steps, git add and git commit. Okay, so add is kind of misnamed. It's not actually adding it to the repository. It's adding it to this holding area, the staging area. And then commit pushes the stage changes into the repo. Okay, so I've got stuff here in Git. I've got some files that aren't being tracked because I haven't added them to my repository. That's okay. If I say git log, I can see a history of what I've done and so on. Okay, now I want to push this over to GitLab so that I have off-site storage. So one time and one time only, I'm going to do the following. Git remote add origin git at gitlab.com. That's an @ sign. Your user ID at git / and then whatever I want to call it. I'm going to call it imp.git. Okay, what this is doing is not actually pushing the stuff over to GitLab. It's basically making a note that I want my local repository linked to GitLab's repository for Nick Macias called imp. Okay, it's just creating this association. You only do that once. When you want to actually push your code, your repository, over to GitLab, you say git push origin master. And that should go off and push it over there. And now it's actually on GitLab. And if you actually come to GitLab and refresh, you should see a project imp. Okay, so make a change to a file, and you want to record that change, add it, commit it, push it. Alright, now anytime you change a file, if you want to record it, git add, git commit, git push. You should never again have to say git init, you should never again say git remote add origin. Okay, for this project. If I have a different project in a different directory and I'm just starting off, I'm going to do git init, I'm going to do git remote add origin. But in here, those are one-time things. Init initializes my local system, git remote add origin basically makes a connection between this and GitLab. So it's mainly add, commit, push. Okay, that's great in a perfect world. And if I want to know if this has worked successfully, what can I do? Make yourself a temporary area. So I'm going to make a directory called test. And test is empty because I just created it. I can try to pull that repository back down from GitLab. Okay, git clone git at gitlab.com :username / repository name.git. And that should create a subdirectory with the same name as your repository. So it said cloning him to imp, and now if I do an ls, I have a directory under here called imp. And if I move into that directory, I've got my Java files in my README.
So does that directory have a Git folder?
And it does. So git push origin master after you've done the git remote add basically takes your local repository and shoves it over to GitLab. Git clone lets you take a GitLab repository and pull it over to your system. And it doesn't have to be a repository you created. If you go to GitLab and you just look at projects that are out there that are open, you'll see, chess programs and something for global domination and all this kind of stuff. If you want any of that code, it's just git clone, git at gitlab.com, the name of the person whose project it is, / the name of the repository.git, and it'll make a subdirectory under your current directory that basically has all the contents of that person's repository.
So does this also do like the git remote add origin? So if you want to push code, you don't have to do that again?
So if I made a change in here, yeah, I could just say git push. All right, so that's a way to sort of check and see if things are correct. And I'm just going to remove that because I don't want this repository copy on my system anymore. I'm just removing the test directory and everything inside it. Right, so this is saying remove everything in this directory. The -r says do it recursively, and the F says force it. Even if it seems like a bad idea, do it anyway. That's why it's a dangerous command. Because if I happen to say star, it'll wipe out everything. All right. So you come back in a few weeks and you forget that you already started this project, right? So you go into this directory and you've got some stuff here and you say git remote add origin. Right, and you get the dreaded message, remote origin already exists, right? Okay, this is telling you one of a few possibilities. One, it could be that, it could be that you've already done this and everything is fine, you just forgot that you did a git remote add origin. That's not a big deal. It could be that you already linked this directory with some other repository. You're in the same directory that you did PA1 in, and you did a git remote add origin to PA1.git, and now you're trying to do PA2 in here, and you're doing a git remote add origin PA2, and it's complaining. Okay. Or it could be that you decided to go over to GitLab and create this repository on GitLab's website, and now it thinks you're trying to push over to something that already exists. So take a breath, right? See what directory you're in. If you're in the right directory and if these are the files that you want, first thing I would say, make a copy. Okay? Before you go too crazy, go back up here and let's just copy imp save. I didn't do that right. Let's do copy dash recursively. Okay, so now I've got a new directory called imp save. It's a copy of my current directory. Okay, go into imp. And if you're trying to do something totally brand new and this is stuff that you already did somewhere else, make a new directory. Okay, if this was where I did PA1 and now I'm working on PA5, make a new directory called PA5. If you've already got code in here that you wrote for PA5, copy it over to that new directory. Okay, and because that's a new directory, it should not have any git stuff in there yet. So you can say git init. And then you can go ahead and you can say, git remote add origin and so on. If you set that all up, right, and we're in here and I did my git remote add origin and I called it imp.git. And then I remembered this is supposed to be called HL. I'm going to get a 0 if it's not called HL, right? And you don't want to move everything over and make a new directory and all this kind of thing. Okay, easiest option, git remote remove origin. But you got to spell it right. Okay, that basically undoes the git remote add origin. Now I'm still going to have my repository over here called imp. That's not going to go away just because I broke that association. But now I can say git remote add origin git at gitlab.com :Nick Macias / and I can call it what it was supposed to be called, which was say hl.git. And then I can say git push origin master. And now if I go to GitLab, I've got my repository called HL. So there's different ways you can kind of undo things that have gone wrong, but you always have the option of going to GitLab, click on a project, come down to settings, come down to the bottom, click advanced, come down to the bottom of that, click remove project. It'll make you type in the project name exactly and then confirm. And now the repository is completely gone from GitLab. And then you can make a new directory on Linux, copy your files over, do your git init, add commit, git remote add origin, push, and you're back to where you should be. If you do that and you make a new repository, don't forget to add me as a reporter if it's something that you're turning in.
Are we going to cover branches at all in this class?
Probably not, because I think it's going to get us into more trouble. But we can talk about it offline if you want. We might. Maybe after PA3. All right. Reasonably comfy about Git. The more you use it, the more you begin to believe that it actually works. And I was kind of suspicious of Git when I started because it seemed like every now and then it would just lose its mind and do something weird, right? But I don't think that's really what's going on. I think it was me doing something different. If you work from more than one source, right? Everything we've been doing so far, we're developing on Linux, we're pushing over to GitLab. Develop on Linux, push to GitLab, make a change, push to GitLab. GitLab's just kind of a sync where we're pushing everything, either so we have a backup or if you're turning it into me so I can pull it from there. If you start getting into things where, for example, you go to the GitLab website and you make a change to a file, right? Or you go to another Linux system and you pull down your repository and make some changes and push it up, then things start getting more complicated. And you get into situations where you've got multiple copies of your repository that are out of sync, and that can get a little strange, and there's other things we can do in that case. But I'm assuming most people are basically developing on Linux server, pushing over to GitLab. And so this should be sufficient for that. But if you want to get fancier, we can talk about that another time. All right, so let's talk about the midterm. Let me just pull it from a file. Oh, I didn't put it in the file. It's on Canvas. So midterm is on Friday. Okay, don't miss your midterm. It's going to be programming in C, programming in Bash, and Linux and Git questions. So 100 points. 4 programming questions, 20 points each. 20 short answer questions, 1 point each. Okay, 12 on Linux, 8 on Git. 2 C questions, 2 Bash questions. So there's a pseudo study guide on Canvas just some of the topics you might see. So Linux, basic Unix commands, right? Things that you should have been doing all along for the past few weeks if you're working in Linux. So echo, cat, ls, changemaod, move, copy, remove, word count and date. I don't ask you about those, but commands like that, right? Make directory, change directory, print working directory. GCC, right? GCC-O, output file name, source file names, right? At least know how to use GCC like that. So GCC-O, name of the output file that you want to create, and then the source files that you want to compile. Variable names, you can say x equals hello, and x is equal to hello, and $x gives you the value of that variable. X equals 2 plus 3 makes x equal to the string 2 plus 3. If you want x to actually equal 5, you could say $paren 2 plus 3, and it'll evaluate. So basic working in a Unix environment. Bash programming, so number sign exclamation, bin bash, first line of the script always. Number sign followed by anything is usually a comment. $1, $2, $3. These give us arguments to a script. So if you have a script and you run it and you type some things after the name of the script, the first thing is available in this variable $1, second is in $2, and so on and so forth.
And $hashtag just stands for whatever.
And $hashtag tells you how many arguments you have, and it's slightly different from argc. So if you say script A, B, C, $number is equal to 3, and this is $1, this is $2, this is $3, this is still $0. So $1230 look like argv bracket 1230. But if this was a C program, argc would be 1234. In a shell script, $number is actually 3. It doesn't count the program name as an argument. That's the only difference between this and argc, argv. Variable assignments, right? Know how to make an assignment. No spaces. You can't say x space equals something. So variable name equals, and then the thing you want it to be equal to. And if the thing you're making it equal to has spaces in it, throw it inside double quotes. If statements, if then else. If then else if. So know the syntax that's posted on Canvas in that how-to guide. If bracket bracket condition bracket bracket new line, then body of the if statement, and then you can either say phi to end the if statement, or you can again say else if bracket bracket new line, then body of the statement. You can say phi, you can say else if, or you can do a single else and then body of the else statement and then phi at the end. So if you don't know those, if you're not comfortable with those, write some scripts, right, that just do if statements. And make sure you're comfortable with them, because they do care about syntax. Okay? And I need it to be the way that it's described in class and described in that sheet. So parentheses instead of brackets don't count. Things like that. While loops. So while bracket bracket condition close close bracket. Do body of the while loop, and then done is your closing curly bracket. And for conditions, make sure you know which one of these to use. If we want to compare x and y as numbers, you got to use this form. You got to say -eq, -gt, -le, and so on. If you want to compare these things as strings, use equal equal or exclamation mark equal. Remember, your variables are always basically strings, but if you say string -eq string, it'll try to convert them into integers, and it'll see if they're equal as numbers. or greater than, or whatever your comparison is.
Isn't elif part of the first if statement, so the phi would have to go after it?
Yeah, I changed my example there. So it's either phi or elif, or else. All right, $, paren, you can put expressions in there like x times x minus 4 times a times c, and it'll evaluate that numerically the way you'd like. Read is for input, echo is for output. Okay, and keep in mind algorithms. So 2 bash scripts, they're not going to be very complex algorithms. Okay, but be thinking about algorithms. C programming, basic syntax, variable assignment, variable declarations, if statements, for loops, while loops, and so on. I will not ask you to do a for loop in bash, but you should know how to do while loops. Character, so we talked about this. Character can be a letter inside single quotes, right? It's like an integer, car. An array is a pointer to a variable type. So an integer array is a pointer to an integer. And character arrays are actually what we consider to be strings, and by convention they have a null character at the end of the actual content of the string. So HELLO also has a 6th character, which is a \0 character 0. That's our convention to know where the string ends. Main program, if you want to deal with command line arguments, integer argc, char ** argv, and argc is the number of arguments including the program name. Argv is the array of characters. You had a million questions and I forgot to let you ask them.
You've answered a few.
Okay,
There's only a couple I have left at this point.
go for it, because we'll continue this tomorrow.
The Linux part.
Mm-hmm.
You said, know what from the GCC parts are, and I'm kind of a question about GCC -C and then GCC SG.
So the only one I'll ask you to know is -O, but -C compiles without making an executable. It gives us what's called an object module. But we're actually going to talk about that after the exam.
Okay.
And -G is what we use if we want to use GDB to do debugging. But I don't have any debugging questions on here. So all you need to know is GCC -O. But we'll talk about -C in a week or two.
No, pretty much it was at that point.
Okay. Yeah.
Sorry if you said it already. Are we allowed any notes?
Yes. 4 pages, double-sided. So you got plenty of notes. Yeah. I just don't want you to bring in a stack of notes and spend the whole exam having to search for stuff. So
4 pages
compile it
double-sided,
down.
so 8 total?
8
or-
total. Yeah. So okay, we'll go through the rest of this tomorrow.